Today I'm going to present and discuss our project, the Household Alarm System.
In our household alarm system prototype, we're using 3 passive infrared PIR motion detectors. The sensors will be responsible for detecting the raw input of the motion for further use and processing by the program/sketch. The other sensing element of this project will be the key code input from the user to disable the alarm. The number of sensors can be scaled to the customer's unique situation.
Regarding the think aspect, the program checks if there is any movement. If yes, then checks for typing. If not, it sounds the alarm. If typing authorizes the user's password, then either temporarily disables the alarm, if correct, or keeps beeping if the alarm is wrong. This can be followed from the graph. Is motion detected? No, it does nothing. Yes, it enables the alarm. The act is, if the motion is detected from the passive infrared sensor, enable the alarm and sound the buzzer. If the correct password is entered, this disables the alarm. The way the system acts currently can also be changed and improved upon in Sprint 2. However, we are happy for this at the moment how it acts, when the alarm is sound.
The sensors that we used in our solution were the 3 PIR passive infrared motion detectors. The digital signal was collected from the sensors and used to determine if the alarm should be sounded. A 16-digit number pad was also used to accept a user-entered code. This code was compared to the original code entered by the user. As a homeowner, I want a motion detector installed for my property so that I'm aware of any unwanted intruders. As a homeowner, I want an audible alarm so I can deter any unwanted intruders. 1 story point equals 0.5 engineering hours. User story 1 will take 5 story points to complete. User story 2 will take 14 user story points to complete. The features for user story 1 are transparency, safety, and awareness of household in the form of intrusion indication. The features for user story 2 are security, safety, and increased awareness in the form of an audible notification for the alarm system.
In the next clip that is about to be shown, you will see a quick demonstration on how our model for the Sprint 1 works. Above is also the link to the GitHub code that was written by Hussein and the other group members.
So this is going to be the project demo. This is the hardware setup. Here we have the Arduino, and then here's the PIR sensor we're going to use to sense people, movement. Here's the keypad we use to enter a password, and here's a buzzer we have. And then there's a breadboard connecting all of it. So we'll upload it. Okay, it's uploaded, and then here you can see on the screen, it detected movement quite soon. So the alarm's ringing because it detected movement. So you need to enter a passcode. The first time you do it, you need to set a password. So you press 16 to enter numbers, and until you hear the sound, because keypad's quite bad. There we go. So you enter 1, 2, 3, 4, 5, 6, 7, 8 digit password. So here we go. You entered an 8-digit password and it works. Right, so right now the alarm's disabled for about 10 seconds. So it's detecting motion again till we make movement. So now you need to enter a password. This time it needs to be correct for the alarm to be disabled. So let's try it out. Okay, hello everybody. Today I will be showing you my Sprint 2. It's called Buggy Alarm. So as you can see, I have a KFC box. This is supposed to be the casing. since we were supposed to actually 3D print a case, but we couldn't afford it because it was like really out of the budget. So we decided to use this instead. So every house we get install this into, we're gonna get sponsored by KFC, and they're gonna get a KFC box inside their house for the alarm system. So now I'll demo the alarm to you. I'll compile it first. Okay. Okay, so as you can see right now, I'm not moving and there's no alarm ringing. But like as soon as I start moving, the alarm picks up and it sounds an alarm. So I need to enter a password the first time it rings. So we'll try entering something. Yeah, the keyboard's kind of bad, so you better press it a couple times. So we'll enter something simple. Right, so the alarm went off because we put in a password. So it's set to delay for 10 seconds. It'll start again after 10 seconds and then just wait for 10 seconds. Right, so it's back on and I'm not moving. And as soon as I start moving, it's gonna pick up on some movement. There we go, and the alarm starts ringing again. And we'll enter a password again. So this time I'll enter the wrong password. Come here, camera crew. So we press enter a random password. You can see it's wrong. It starts ringing again, and we'll enter a password again. Right, so you see the alarm didn't go off this time. So that means the alarm system works, proving the buggy alarm is the best choice for your house. Secure your kids today.
All group members were equally working on the sprint and contributed in different ways to work collaboratively to complete the task. This is the breakdown of the contribution by each team member. Rhys generated ideas, assisted in presentation and design, provided information for presentation and design. Anthony assisted in development and helped provide information for the presentation and design. Zach assisted Hussein in development, helped with design of presentation. Hasnain wrote the code in C and helped develop the project. As you can see from our Trello board, consists of mostly completed tasks such as writing the code for the motion sensor, buzzer, and keypad. This also includes debugging and optimization of the code to work effectively. The tasks such as define the sense, think, act paradigm were also completed for the presentation. Assigning burn down and user stories were also achieved in order to help the group members to stay on track throughout the completion of Sprint 1. Lastly, the hardware was built and tested with the code. And in our backlog, as you can see, are the list of tasks that need to be completed for Sprint 2. In the following slide, you can see how the burn down chart was assigned. Each day was given 3 hours to work this task from the beginning of the project. We fell short earlier on, however we worked on the task more often and more consistently when the Sprint 1 due date approached. Here are some photographic images of our hardware setup. Cleaning and refining this is one of our major goals for Sprint 2, for this to become a more clean and efficient setup. As you can see, the Arduino board is connected to the breadboard. This breadboard connects all the other motion sensors and input devices back to the Arduino board. More devices will be added to the next sprint to make this a more well-rounded device. Challenges faced during the sprint were plenty, mainly being due to the code and the hardware. Most tutorials and libraries were not compatible with the number pad we had, so code had to be developed from scratch for this setup. The number pad needed to be constantly polled to check what was being pressed in order to get a value. This resulted in having the same number multiple times if the user wasn't fast enough in pressing the keys. This created some issues in developing our code and hardware. We had to work around this to ensure that we could minimize this issue as much as possible. In Sprint 2, we will further develop these bugs and issues to make the system more well-rounded.
The only extensions to the project from Sprint 1 was the addition of 2 more motion sensors. The 3D printed box and the LCD screen and the RFID sensor were not added in Sprint 2 because of time and cost restraints.